5th grade. Today we're going to be doing Module 2, Lesson 22, and we are going to be continuing dividing, but you'll notice that we're getting into more difficult problems, and today we're actually going to be getting into two-step division problems. So I'm going to show you what that looks like today. Just make sure you have out your Lesson 22 notes and that you're ready to follow along with me. So for our first problem, 590 divided by 17, what I'm actually going to do first is I'm going to set up my standard algorithm. So I have 590 divided by 17. I know usually we start off by doing the estimate, but during this problem, I'm going to show you why I want to set up the standard algorithm first. Because when I do this, what I see is that I'm not trying to fit 17 all the way into 590 like I would with the other problems that I was doing. What I'm trying to do now is I don't go automatically all the way to the back. I think, can 17 fit into 5? No, it can't, but 17 can definitely fit into 59. So what I need to do is I need to make an estimate just based off of this little problem right here. So it's kind of like I'm figuring out 59 divided by 17 equals what? And then that answer is what I will put right here and then continue solving my problem. So 59 divided by 17 is the part that I need to round and then estimate for. So to do this, I could change this 17 to 20. So remember from the previous lessons, I could think about, well, what multiple of 10 or what number is this closest to? So I'm going to round it up to 20. And then 59 is really close to 60, and 60 is a multiple of 20. Remember, you can always list out 20, 40, 60, list out those multiples of 20, and see which one gets as close as possible to your dividends. So now I have 60 divided by 20, and this is a problem that I know how to solve. So I have 6 divided by 2, and 6 divided by 2 equals 3. And so then when I come over here to my actual standard algorithm, this little question mark I have right here, I'm going to try to fill that in with a 3. And pay close attention to where I lined up this number. I didn't put my 3 all the way back here, because if I put my 3 over here, what that would show is that I think 17 fits into 590 3 times, and that's definitely not correct. So I need to make sure that I put the 3 right here, because I'm showing that 17 fits into 59 3 times, and that makes a lot more sense. So then to actually solve for what 17 times 3 is, off to the side real quick, I can solve for 17 times 3. 7 times 3 is 21, 1 times 3 is 3, 3 plus 2 is 5, and that gives me 51. Using my number sense, I can see like, okay, that's probably as close as I'm going to get to 59 without going over, so I'm going to write 51 right here, because 17 times 3 is 51. And now I need to subtract. So I do 9 minus 1, which is 8, and 5 minus 5, which is 0. I'm not going to write the 0, though. Now, normally you would think, okay, this is where I stop. I have 3 remainder 8s, but you do not, because we still have this place value that we need to work with. So I actually need to bring this place value down and continue solving. So now, the problem that I'm trying to solve, and this is why it's a two-step problem, is that I have this 80 right here, and I'm now trying to figure out how many times can 17 go into 80. So now it's kind of like I'm solving 80 divided by 17, and again, this is going to give me the next part of my quotients. And what I'm going to do is I'm going to estimate to help me solve that. So 17, again, I could just round this to 20, and thankfully, the work is already kind of done for me because I can evenly divide 80 by 20 already, so I don't have to worry about rounding this number right here. So I'm going to do 80 divided by 20, we'll cross off the zeros, and then I have 8 divided by 2 left. 8 divided by 2 is just 4, and now I am going to put the 4 right up here in my ones place, so I'm showing that 17 times 4 fits into 80. And now I'll actually solve for 17 times 4, see what that equals. 7 times 4 is 28, 1 times 4 is 4, and 4 plus 2 is 6. And again, using my number sense, I can think about, does this number make sense? Well, I think it does because there's only a difference of, what would that be, 12 between 80 and 68. So I can stop right here. So 17 times 4 is 68. I subtract. I cannot do 0 minus 8, so I cross off the 0, cross off the 8 and borrow from it, so it becomes a 7. And then this 0 becomes a 10. So then I do 10 minus 8, which is 2, and 7 minus 6, which is 1, which gives me my final answer of 34, remainder 12. So that is the only difference with these problems today. You're still doing that same estimate step. You're still dividing, and we're still eventually going to be checking. The only real difference here is that we're going to have 2 steps where we have to divide, and we just need to remember to bring down that next place value. So now for the check step, this is only going to look a little bit different, because what we're going to do is we're still going to multiply the stuff on the outside, so 17 times 34, so the divisor times the quotient, except when I go to multiply this, I'm actually going to set it up like this, so like a standard algorithm, so I can actually solve and make sure that my numbers are correct, instead of just laying them out like that. So 7 times 4 we said is 28, 1 times 4 is 4, and 4 plus 2 is 6. Add that 0, then 3 times 7 is 21, and 3 times 1 is 3 plus 2, which is 5. So I have my 2 partial products, and then I add everything up for 578. Now before I continue, I need to add on my remainder, so I could just set up another standard algorithm just like this, and do 578 plus my remainder of 12. 8 plus 2 is 10. 1 plus 7 is 8, and 8 plus 1 is 9, and then 5 plus nothing is just 5. 590 is the same thing that I had for my dividend, so I know that I have the correct answer of 34, remainder 12. So, like I said before, these problems, again, are pretty similar. You're just adding an extra step, and then when we go to check, you're just setting up everything up and down vertically so that you can actually solve instead of just doing most of this stuff as mental math. So we're going to go ahead and move on to our next problem now. So for this next problem, we are going to be solving for 887 divided by 27. So 887 divided by 27, just like this. Now, again, what I'm going to do is I'm going to start by setting up my standard algorithm. So we have 887 divided by 27. Remember, I'm not just automatically going all the way to the ends, thinking how many times can 27 fit all the way over in 887. I'm thinking about first, well, can 27 fit into 8? No, it can't. But 27 can fit into 88, so I am going to estimate for this first step. So I'm going to take this number 88, because that's what I'm trying to fit into. So I have 88 divided by 27. And just like before, when I estimate, I just need to round this number, usually to its nearest tens place, or whatever the nearest place value is. So I have 30, because 27 is closer to 30. And then I think about my multiples of 30. Well, I could use 30, 60, 90. And 90 is really close to 88, so I think I'm going to use that. And then I have 90 divided by 30. Cross off those zeros. 9 divided by 3 is 3. And that lets me know that I could probably put a 3 up in my quotient, or at least something close to that, to get my problem started. So I'm going to solve for 27 times 3 off to the sides, and see if that does actually fit into 88. So I do 7 times 3, which is 21, 2 times 3, which is 6, and 6 plus 2, which is 8, which gives me 81, which is great because 81 is as close as I'm going to get to 88 without going over. So I leave that 3 up there, and then I go ahead and subtract. 8 minus 1 is 7, and then 8 minus 8 is 0. I'm not going to write that 0, though, so I don't get myself confused. And then I'll bring down this 7 right here. Now, I'm trying to figure out how many times can 27 fit into 77. Well, I know 27 times 3 is 81. So that is going to be too big. So I could either use my number sense right now and see, okay, well, 27 times 3 is really close, but that's not going to work. So I should probably just do 27 times 2, because that's the next lowest factor. Or if you need to, you can always still do the estimate. So I have 77 divided by 27. 77 divided by 27, I can change that to maybe like 30 divided by 60. And then when I do that, I would get 2. So now when I put that 2 there, I now need to figure out what 27 times 2 is. And just make sure that when you are multiplying for this number right here, you are not multiplying this together as a whole. So when you get to this part, you're not doing 27 times 32 and writing that number there. We're not doing that. I am just taking this number that I see in my ones place over in my quotient, and that is what I'm multiplying by for this section right here. So 27 times 2 will give me 7 times 2, which is 14. 2 times 2 is 4, and 4 plus 1 is 5. So 54 is as close as I'm going to get without going over. And then I do 7 minus 4, which is 3. 7 minus 5, which is 2, which gives me a remainder of 23. My remainder is not larger than my divisor, so I know that I'm on the right track. So I have 32, remainder 23, and now I'm going to check my work. Remember, when I check my work, now I'm just setting it up as a standard algorithm. So I have 27 times 32. This is now where we'll take that whole number and multiply it. So 7 times 2 is 14, 2 times 2 is 4, and 4 plus 1 is 5. Add a 0. 3 times 7 is 21. 3 times 2 is 6. 6 plus 2 is 8. So I add up my partial product. 4 plus 0 is 4. 5 plus 1 is 6. And 8 goes right there. So I have 864. Remember, that is not where I stop because I still need to add on my remainder. So I do 864 plus 23. So I have 4 plus 3, which is 7. 6 plus 2, which is 8. And then 8 plus nothing is also 8. So again, what I got right here for my check matches my dividend, so I know that I am correct, which means my final answer is 32, remainder 23. And that is how we solve these problems. Like I said before, these problems are very, very similar to what you have been doing so far. So if you have this estimate step down, you're going to be great. And then just remember that you just have to bring down usually just one number for this lesson. And just be careful where you're putting numbers at the top. So you are going to do the you try problem on the back of this worksheet. So you're solving for 839 divided by 41. Remember that tip, write down your problem first and a standard algorithm, and then start your estimate steps as you solve. Good luck today and have a good time.